Hello all, welcome back to my YouTube channel all about VLSI. Hope you're all doing good. In this video, we are going to discuss about ripple carry adder and carry look ahead adder. Let us see what is meant by this ripple carry adder and carry look ahead adder. Okay, so first let us start our discussion with the concept of ripple carry adder, or it is also known as the binary parallel adder. Okay, it is also known as binary parallel adder. So what is this ripple carry adder or binary parallel adder? In the case of, let us take a full adder. Okay. In the case of a full adder, it is only going to add uh, the single bits. Okay. A is a single bit, B is a single bit, and C is a single bit, and we will get sum and carry. Okay. In this particular case, A, B, and C are single bits. Okay, a b c are only single bits. Okay, the addition operation is happening between only single binary values. Okay, so if you want to add multiple bits, multiple binary bits, we are going to choose the ripple carry adder or carry look ahead adder, where we have multiple number of bits, more than one bit. Okay, now let us see the structure for this particular ripple carry adder, or let us consider a 4-bit ripple carry adder. Okay, where we are going to add 4 number of bits. Okay, 4-bit binary, 4-bit ripple carry adder. Okay, that means we are going to add, let's say for example, let's take 1010 and 1111. Okay, this two we are going to add. Okay, so let us take uh, this as a3, a2, a1, a naught. Okay, this is b3, b2, b1, b naught. Okay, now let us assume that initial carry to this particular ripple carry adder, that is c in, is equal to 0. Okay, let us assume that initial carry c in is equal to 0. Now here uh, a3 is msb, which is equal to 1, a2 is equal to 0, and a1 is equal to 1, and a naught is equal to 0. Whereas here b3 is msb, which is equal to 1, b2 is equal to 1, b1 is equal to 1, and b naught is equal to 0. Okay, now let us try to add these two numbers, 1 0 1 0, addition with 4 ones, 2 3 4. So 0 and 1, and initial carry is equal to 0, so 0 plus 1 is equal to 1, and there will be no carry propagated, and 1 plus 1 is 0. Carry is being generated here, and here the carry which was generated when we are adding this two bits 1 and 1, the carry which was generated will be propagated to the next stage. Here you can see the sum is 0, whereas the carry is propagated to the next stage, and it is being added with the next stage bits. Okay, now what we are doing, 1 plus 0 plus 1, which is equal to sum is 0, and the carry generated in this particular stage, third stage, that carry will be propagated to the next stage, that is the fourth stage. Okay, here it will be equal to 1. So triple 1, 1 plus 1 plus 1 is equal to 1, and the carry will be generated. So this is the output carry. Okay, so this is first stage and no carry is generated, and this is, let's say this is sum s naught. Okay, and this is second stage, and this is s1, and this is third stage, this is s2, sum s2, and this is fourth stage, let's say this is as s3. Okay, and the carry which was generated in the second stage is 1, this is, let's say, c1, sorry, c3, let's denote it as c2 because it was generated in the second stage, and this is third stage carry. Okay, let's say it as c3, and this is the final carry out, c out. Okay, so you can observe here the addition between the two bits in one particular stage, and the sum has been generated along with the carry, which was propagated from one stage to the next stage. Here you can observe the carry was propagating from one stage to the another stage, and it has been added with the next stage bits. Okay, so since the carry is propagating from one stage to another stage, that is, it is being rippling from the one stage to another stage, it is known as ripple carry adder. Okay, it is called as ripple carry adder. And you can observe one stage, let's say suppose this third stage, in this particular third stage the addition is happening only when the carry which was only when after the carry being generated in the second stage. Okay, the third stage addition is happening only when the second stage carry has been generated, and the fourth stage addition is happening only when the carry was generated in the third stage. Okay, so there is a dependency on the carry which is being generated in the previous stage. Okay, so here there is a dependency in the carry generated in the previous stage. So this is the disadvantage of ripple carry adder actually. Okay, so that is why we are going to the next adders types, which are known as carry look ahead adders, that we will see. Okay, now so this is the disadvantage. What is the disadvantage here? The carry which is generated at the particular stage, the second stage or the third stage, the present stage is depending upon the previous stage carry which is being generated. Okay, so this is the concept of ripple carry adder which is working. Now let us see the diagram for this ripple carry adder. So ripple carry adder is made up of 4 full adders. Wait a minute. So the ripple carry adder is made up of 4 full adders. Let us take this as full adder 1, and let us take this as full adder 2, and this as full adder 3. Okay, and this is full adder 4. Okay, since it is a 4-bit full adder, we are taking 4 full adders. Okay, for 4-bit we are taking 4 full adders. Okay, and for this full adder 1, the inputs are A1 and B1, and for full adder 2, the inputs are A2 and B2. Okay, so these are the inputs, and for full adder 3, the inputs are A3 and B3, and for full adder 4 we have inputs as A4 and B4. Okay, and the output of full adder 1 is S1, and output of full adder 2 is S2, and output of full adder 3 is S3, and output of full adder 4 is S4. Okay, and let us assume this is the carry in Cin. Okay, initial carry. Okay, in this particular case we have taken Cin as 0. Now this is coming from the previous stage. Okay, this is the initial carry. Now, S1, and we have carry. Okay, the carry 1 which is being generated by the full adder 1 is given to full adder 2 C1. Okay, and here C2 is given to full adder 3 C2, and C3 is given to full adder 4. Okay, and this is the output carry which is being generated from this particular circuit, C out. Okay, so this 4 bits of sum constitutes the 4 bits of output result. Okay, and A4, A3, A2, A1 are our 4 bits, and B1, B2, B3, B4 are another 4 bits. Okay, so if A3, A2, A1, A0, let's say it is 1 1 0 0, and B3, B2, B1, B0 are 0 1 0 1. Okay, so like this we will add 4 number of bits together. Okay, so like this, since there are only 4 bits, there are 4 full adders, and if we have more number of bits, we will have more number of full adders. Okay, yeah. So that was about the ripple carry adder. And the disadvantage also we have seen, if the full adder 2 wants to perform the addition operation, it is waiting for the previous stage carry which was generated by the full adder 1. Here if full adder 3 wants to perform the addition between A3 and B3 bits, it is waiting for the previous stage carry, that is C2. So there is a dependency upon the generation of previous stage carry. And if full adder 4 wants to perform the addition operation, it is waiting for the carry generated in the in the previous state, that is C4. Okay, so it is waiting for the generation of the carry. Okay, so due to this, the propagation delay increases, or the delay to get the output is increasing. Since if the carry delay has increased, that is the generation of carry is increased, then that is the propagation delay is getting increased, then the output we will get the output at a delay. Okay, so that is how the ripple carry adder works. Okay, so that's all for this session. So if you like this video, please like, share and subscribe to our YouTube channel all about VLSI. In our next session, we are going to discuss about carry look ahead adder. Thank you.